G'day chemistry students. In this video we are looking at dot point 8.2.1. We're going to be revising some chemical reactions that we saw in our organics topic in module 7 and applying what we know about some of those reactions to design some tests that could be undertaken to identify functional groups present in unknown organic chemicals. Let's get into it. So first off, we know that there are a wide range of organic chemical reactions and that certain combinations of organic chemicals under certain conditions will proceed and actually undergo a reaction. Some reactions we've seen are really easy to sort of observe that they've proceeded, and others are a little bit more difficult. So if we're going to do some chemical testing, we really want to be looking for chemical reactions that are very easy to observe changes in and to prove that a chemical reaction has or hasn't happened. So these are some ones that we've done before that are really easy to observe. The first one is an addition reaction where we add halides like bromine water to an alkene. So in this case, what we have is a bromine water at the bottom, the alkene at the top. It's being shaken and mixed. And as the bromine, which has that orangey yellow browny color, interacts with the alkene and the double bond, an addition reaction happens. The bromine gets consumed and becomes a bromoalkane, leading to a colorless liquid. Really easy to recognize and see. Similarly, for oxidation of alcohols, we can combine an alcohol, generally primary or secondary ones, with an oxidizing agent. So that could be a chromate, or in this case, it seems to be potassium permanganate. And when that alcohol is being given time to react, the permanganate will be consumed. Once the permanganate's been consumed, it will decolorize the liquid, as we can see on the right. Something else that's really simple to do is do some reactions with organic acids. We know how acids behave, especially just with an indicator like litmus paper. We can identify organic substances as acids quite simply and easily using a technique like a chemical indicator, or maybe something like an acid carbonate reaction, which doesn't even need a chemical indicator to see what's going on, because as we know, an acid plus a carbonate leads to salt, water, and the characteristic bubbling of carbon dioxide gas. Knowing some of these chemical processes, we can begin to identify functional groups on chemical compounds. In particular, the syllabus requires us to come up with tests for carboxylic acids, alkenes, and alcohols. They've been outlined here. So some tests that I've already shown you or talked about: a blue litmus test or a sodium carbonate solution. Really easy to identify an acid, in particular a carboxylic acid. For an alkene, a bromine water test is going to be really useful in being able to determine the presence of a double bond. For alcohols, there are lots of tests that we can actually do. So by doing a bromine water test, we can find that there's no color change because bromine water doesn't really react with alcohols. That only happens in a substitution reaction, but won't happen under general lab conditions. It's not a spontaneous process. So a negative test here could indicate that an alcohol may be present, certainly not a double bond. We could also do an oxidation process, like we saw in the GIF. We could do an esterification process, so combine our unknown substance with a little bit of acid and a carboxylic acid and put that under heat and see if you can produce an ester characterized by a very distinct smell. The other reaction, and this is not something that we've seen before, but hopefully we'll get a chance to do in the lab, is to add a small piece of sodium to the alcohol. Now, effectively, what the alcohol will do to the sodium is the same as what we would see for any other metal acid reaction. But because the alcohol is a ridiculously significantly weak acid, it will only react with the sodium in very, very, very small amounts. Nothing explosive, nothing that generates a ridiculous amount of heat or gas. And yes, so as a result, this is a chemical where you do get to see this really cool slow reaction with sodium. Hopefully we'll be able to do that one. In class, what we'll try and do is develop a little bit of a flowchart. We already know that when doing organic chemical reactions, there are a lot of safety considerations to take into account. Things like flammability and reactivity really need to be at the forefront of our minds. And as a result, we may not want to do some of these reactions. Things like flammability, reactivity, as well as the potential to produce toxic and harmful byproducts are all things that we need to consider when doing some of these processes. So we'll come up with a flowchart that allows us to identify unknown substances really quickly and easily, while also ensuring that we eliminate the opportunity to accidentally combine chemicals that may end up resulting in a particularly dangerous reaction. Thank you very much, everyone. In the next video, it's going to be our final video, actually. We're going to be looking at chemical synthesis and design. Just a few things to consider in industrial processes that are being used to produce chemicals and the design of those processes themselves. But until then, have a good one.